Assalamualaikum and hi, my name is SYAHIRA with KHUSYAIRI. So today I would like to present about figure 7.3 schematic control diagram for main incoming. Okay, so firstly we can see there is incoming supply from PND, which is 3-phase AC supply. Okay, and then we can see we have CT, current transformer, which is 3 unit with step down 150 to 5 ampere current transformer. And then we can see here we have connector to connect the wire, and then we also have MCB. Okay, MCB is stand for miniature current circuit breaker. Okay, it will automatically switch off the electrical circuit during any abnormal condition in electrical network, such as overload and short circuit condition. So it will protect the kilowatt hour here. Okay, and then there are also 3 phase at the load to main bus bar, which is red, yellow, blue and neutral. One more. Okay, so this MCB will connect to red, yellow and blue, and then this one at the kilowatt hour will connect to the neutral part. Right. Okay, secondly, at this part, okay, this is the main supply indicator, which is when the supply is in, the indicator will light up. Okay, there are also heater here to control the humidity of the circuit. Okay, there are also MCB and also switch here. And then for the next part, we have a circuit breaker here, circuit breaker, and then also step down current transformer here, which is 4 unit and 150 to 5 ampere. Okay, we can see here we also have relay. Okay, this is relay. So when the fault occur, then the relay will detect or trace the fault, and then the relay will give the signal to the circuit breaker. Then the circuit breaker will open, so it will protect the circuit lah. Okay, and finally, at this part we have selector switch here. Okay, it will select the rate of red, yellow and blue. Okay, and then this is emitter relay, emitter analog. The function is to record the value of the current. Okay, and then there are also current transformer here and here. So at this part, we also have selector switch, and then voltmeter. Okay, the function is to record the value of the voltage. This one is to record the value of the current, and then this one is for the voltage. And lastly, we have the bus bar indicator light. Alright. This schematic control diagram is to change the 3-phase to single phase. Okay, so that's all from me. Thank you.
Hi and Assalamualaikum. My name is Anura Shura binti Muhammad Nur Zaki. My metric number is AE1800085. So today I will explain about figure 7.4 schematic control diagram for outgoing feeder CW earth fault relay. First of all, it starts from the incoming supply from main bus bar, which is 515 214 volt 3-phase AC supply. So it will connect it to the red, yellow, blue and neutral line, and then it connected to the MCCB, connect to the CT current transformer, and lastly is to the load. First condition is a normal condition. So when a normal condition, it will start at a red wire and then go through the MCB, and then it will go to the point 3 and 4. So at here there is a open contact, so which means when there is no overcurrent or overload that happen in the city, it will go back to the red wire. For the second condition, when there is earth current fault, what will happen? When there is overcurrent or overload in the system, the EF will sense the fault when there is overcurrent. So when the fault exists, it will go to the coil 1 in 8, and then will make the close contact, and this coil make the close contact, and it will go to the shunt trip, and then the shunt trip will send the signal to the circuit breaker, and then the circuit breaker will cut off the current and to this in the system, so that there is no current flow in this system. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is BATRISYIA BALQIS binti JAIZAN HADI with matric number AE180040. And now I will explain figure 7.5 schematic control diagram for outgoing feeder C/W earth leakage relay. Firstly, it starts with incoming supply from main bus bar that source to our 4 wire red, yellow, blue and neutral line. This is 3-phase. And then there are directly connected to MCCB, molded case circuit breaker, go through to the ZCT, zero current transformer, and lastly to the load. As we can see here, the ZCT is connected to panel 1 and panel 2 of our relay, and this ZCT is in looping condition. It is they will go back to the red line when there is no earth leakage happen. Okay, so what happens when there is earth leakage? Okay, this ELR is to sense earth leakage and open a circuit break when the leakage current exceeds the preset value. Okay, so it looks like this. When the leakage current exceeds the preset, it will go here and to the coil of LR, and it will make the contact close. This contact is normally open when there is no current leakage, but when earth's current leakage happens, this LR coil will make this contact close, and this will go to the shunt trip coil, and this shunt trip coil will give a signal to the MCCB to cut off the current, so there is no damage happen to our load. So here there is no current flow through this 4 wire. And as we can see here, this panel, which is 7, is connected to the neutral and shunt trips coil. And for panel 9, it connects to the red line. That's all from me. Thank you.
Assalamualaikum. My name is RAUQAH BINTI from section 3 group 1. So today I would like to explain about the control diagram of power factor condition of capacitor bank. So as we can see, there is the incoming of the connection is from main bus bar, which is consists of 3 types of cable, which is red, yellow and blue. The cable is connected to the tapping voltage, and at the other side is connecting to the capacitor bank, which is at the rated voltage at 440 volt. The capacitor bank is connected to the exhaust fan switch, which is auto off on, and also connected to the capacitor component, while the tapping voltage is connected to the meter, which is which will where the meter will be functioned when the voltage is below than 0.4. Whenever the circuit is uh, want to be functioned, it will be triggered whenever the voltage is below than 0.4, and the notice will be sending to the client. Capacitor bank can function to ensure that power factor values reach the value of unity as close as possible. The other function of capacitor bank is to act as reactive current generator. I think that's all for my explanation. Thank you.